So a couple notes here. If an object has a point, line, or plane of symmetry, the center of mass will lie on that symmetry location provided the object is made of homogeneous material. So if you have a ring or tube, you can see that the center of mass is going to be at the center where there is no material, but that's perfectly fine. Rectangle, it's right at the geometric center. You can use diagonals to find out where that point is, or you can see that the dashed lines as well. And there's like a C channel. Again, we're assuming that's symmetric. If you put dashed lines in the middle horizontally, then you're making two symmetric pieces, the same mass. So the center of mass should lie on this line. So once the center of mass is found, again, we can use our basic techniques like Newton's laws and linear motion equations, projectile motion equations, energy conservation, so all those things that we learned to predict the behavior of the center of mass point. Okay, so we are gonna still do that part. We are learning how to figure out the center of mass point first. And next is an example problem. So example 27. A table has a top which weighs 20 pounds and 4 legs, each of which weighs 3 pounds. The top of the table is 1.5 inches thick, and determine the location of the table's center of mass. So axes are given x, y, z. They're a little bit different than we usually take, but that's perfectly fine. We have to use this axis. We need to find out where the origin is first. So given is a wooden table with some measurements, and the figure is on the right side. We are trying to find the location of the center of mass. And some assumptions. First of all, there are 4 legs, and we're going to assume that they're uniform and also untapered. And so we're already assuming that the material is homogeneous, so it's the same wood, same homogeneity, so that the density is the same overall this table. And plan is, again, for the center of mass. To find the center of mass, you need to, if the object is a little bit complicated, you need to split into pieces that are easy to figure out the center of mass using geometry. And then we will use our center of mass equations. Again, we're not going to integrate, okay? That integral was more irregular shape. So we can split this into pieces to make it more regular shapes so that we can use our summations instead of integration to figure out things. How do we estimate? So for this one, let's just look into this a little bit more carefully. I want to zoom into my figure. Where is the origin? So let's follow the lines so that see where they intersect. If you look at the x and y axes, they are on the top of the surface, right? On the top of the table. So right here is the origin. I hope you can see that. I'm just following the lines from x and this y and z. That is the intersection, not the bottom of that table. Okay, so that is the origin, and remember that we had a thickness. So from here to there is given in inches. Gonna remind myself what was the value. It says 0.5 inches thick. So this portion here is 1.5 inches. Okay, but of course we have inches, we have feet, so we got to make sure that we are doing this consistently. So we're going to think about the unit conversions later. So that is important that you choose your origin, and if it is given to you, you see where it is exactly, so you don't make calculation mistakes, because when you find the center of mass for individual pieces, you are writing x, y, z coordinates from the origin. So it's really important that you know where it is. So how do we estimate? We are going to look for x and y. X and y is much easier, right? So because we know that 4 legs are uniform, so there's going to be like symmetric one for each of them. So if you think about the center of mass, it's going to be at the center of that table. And where is that x? If you draw a line to x and then y, those are the x and y points on the x and y axes. So those are going to be the center of mass points. That means they are going to be just half of that length of the table, so 3.5 feet divided by 2, and we're going to get 1.5 feet for 1.75 feet for the x center of mass and 1.75 feet for the y center of mass. So in terms of the dimensions, z dimension is more complicated in this problem because x and y you can simply find it because of the symmetry, and you don't even need to use the equations to prove it. There's a nice geometry and symmetry. Okay, so for the z, we got an estimate. Again, if you look into this closely, so the leg height is 2.5 feet, but the table thickness is 1.5 inch. Okay, so that has a thickness as well. If you remind yourself what the weights of each piece here is, the tabletop weighs 20 pounds, but the legs weighs 3 pounds each. So for the legs, we know that, again, since they are uniform, the legs will have a center of mass point right in the center of this rectangle, right? So it's kind of turns out to be like about this point. It's going to be half of 22.5 feet, but that is not measured from the origin. Remember, the origin is at the top, so you need to add up 1.5 inch. So that's what we're going to do later. But to kind of realize what we have here, we have 4 legs, and I put that mark here. At this mark, all the 4 legs center of masses lies on this point along the z direction. So that's about half of that 2.5 feet. But at the top, the table is 20 pounds. So 20 pounds of tabletop versus 4 times 3 pounds. It's 12 pounds of legs at this marked point. And you're going to see that it's going to be in between, right? And it's going to be closer to the tabletop. So maybe it's somewhere here along z direction is going to be our center of mass for z. So it's definitely going to be less than 1 feet. Okay, so that's why we are making this estimation here. We're saying that z center of mass is going to be less than 1 feet. I hope that part is clear, but we will also solve it and we'll get that. So by symmetry, we know that x coordinate of the center of mass is 1.75 and y is also 1.75 because it's easy to solve, so we don't really need to show the work for those. And all we need to find is the z center of mass point and from the origin. So again, we don't need an integral, we are just using summation. We have 5 pieces, 4 legs and the tabletop, so that little n is going to be 5 for us. And the good news is the legs will be at the same level. The center of mass, z values for legs are going to be all at the same point. So once we find one of them, all 4 will be at the same distance. Okay, so in this equation we have masses on the top and bottom. However, if we multiply top and bottom by g, we get this. So why do we do this? Because what is pounds? Is it a mass unit or a force unit? Pounds is a force unit, right? So they're not giving you the mass, but in the equation here, we have mass. So yeah, this equation has mass in it. How do you make it weight? Weight is mg, right? So if you multiply everything by g, you are going to introduce weight force. And you're not going to change anything if you do it at the top and the bottom. Both of them are going to be weight force. And you don't need to really convert the pounds to slugs to figure out this problem. Okay, because pounds is not a mass unit. So this is what we are doing. We are multiplying top and bottom with g to make it a pound or a force or the weight force. Okay. And again, once you distribute it, g is going to come in right here, and then m times g becomes w, and we also have w at the bottom. The top one is for each piece, the bottom one is for the the total weight. Okay, so let's have a table again. Hopefully you realize that having tables is really helpful. So that's what we are going to do. And there are 5 pieces. The first one is tabletop, and there are 4 legs. That's the first thing we do, like what are the parts. And at the bottom, we're going to put the total. So the weights, the tabletop is 20 pounds, that's W1, and the rest of the weights are the legs, and they're each 3 pounds. Total is going to be 32 pounds, right? That's the entire mass. Entire weight of the object. And center of mass location, so you're going to figure these out. And tabletop is gonna be, so let's focus on this again. Tabletop is gonna be right in the center, so so you're thinking in terms of Z, and this is Z, and that is 1.5 inches. Half of that is gonna be where the geometric center is, right, along the Z direction. So try to isolate everything else. Just focus on Z direction. Z is going down the plane, as we showed it here. And that blue line is really the thickness of the tabletop. And the geometric center is going to be in the middle. So 1.5 inches divided by 2 is 0.75 inches is our center of mass point along the Z direction for the tabletop. Okay, I hope this is clear. And now we will look into the also the legs. Okay, and I think I'm gonna do that on the next video.